Today in the maths class, so we deal with the topic trigonometric up to transformations, trigonometric equations and inverse trigonometric functions. So to start with the lesson, before starting, so first we will see the synopsis and the formulae related to this corresponding topics. So we had in trigonometry we studied about the basic identities, which is sine square theta plus cos square theta is equals to 1 plus tan square theta is equals to secant square theta, and 1 plus cot square theta is equals to cosecant square theta. And we know the signs of the trigonometric functions in various quadrants. And in the first quadrant, so all the trigonometric functions are positive, and in the second quadrant, the sine and the cosecant functions are positive and the remaining are negative. And in the third quadrant, the tangent and the cotangent of angle are positive and the remaining are negative. And in the fourth quadrant, cos and secant are positive and the remaining are negative. Now we shall see some of the standard trigonometric, standard angles of some trigonometric functions. Let's say the sine, these are the values of a sine, cos and tan theta values for a specific angles. Sine 0 is 0 and cos 0 is equals to 1, tan 0 is equals to 0. And sine 30 is 1 by 2, cos 30 is root 3 by 2, tan 30 is 1 by root 3. Sine 45 1 by root 2, cos 45 1 by root 2, tan 45 is equals to 1. Similarly, the other angles, sine, cos, tan of 60 degrees are root 3 by 2, 1 by 2, root 3. And for 90 degrees, sine 90 is 1, cos 90 is 0, and tan 90 is not defined. So similarly, the values of 180, 270 and 360 are written as tabulated as like this. Shall proceed to now trigonometry formulae related with the negative angle. No, sine minus theta is equals to minus sine theta, cos minus theta is cos theta only, whereas tan minus theta minus tan theta, cosecant minus theta minus cosecant theta, secant minus theta secant theta, and cot minus theta is cot theta. So for sine, cosecant, tan and cot are directly we say for trigonometric of minus theta is minus of the trigonometric ratio. Otherwise, this cos and secant, the speciality, they are the even functions. So let's take up now in the first the allied angles, trigonometric the ratios for allied angles. We know the allied angles are nothing but angles like 90 minus theta, 90 plus theta, 90 minus theta, 90 plus theta, 180 minus theta, 180 plus theta, 270 minus theta, 270 plus theta, 360 minus theta and 360 plus theta. 360 plus theta. So 90 minus theta comes under first quadrant and 90 plus comes under second quadrant. 180 minus theta comes under the second quadrant, 180 plus under third quadrant. Similarly, the other angles. Let's consider here ASTC rule. It is just repeated. So all trigonometric ratios are positive in the first quadrant. Sine, cosecant are so positive in the second quadrant, etc. So let us consider the allied angles. When I take up here the 180 minus theta, as I told you that 180 plus theta comes under third quadrant, 360 minus theta comes under fourth quadrant, etc. So these are the values which are already we defined in the lower class. Let's go with the compound angles. So the compound angle formulae. We know sine A plus B is nothing but sine A cos B plus cos A sine B. Whereas sine A minus B is equal to sine A cos B minus cos A sine B. So if it is plus sign, you take it as a positive. If it is minus sign, take it as a negative. So cos A plus B is equals to cos A cos B minus sin A sin B. If it is plus sign, you have to take up minus sign. Cos A minus B is equals to cos A cos B plus sin A sin B. Whereas tan A plus B is equals to tan A plus tan B by 1 minus tan A tan B. And tan A minus B is equals to, change the sign here, tan A minus tan B by 1 plus tan A tan B. Cot A plus B is equals to cot A cot B minus 1 by cot A cot B plus cot A. Whereas cot A minus cot B is equals to cot A cot B plus 1 divided by cot B minus cot A. So these are the sum of the formulae which are related with the compound angles. So the very much useful formulae are here. Tan pi by 4 plus A is nothing but 1 plus tan A divided by 1 minus tan A. Whereas if we take minus sign here, pi by 4 minus A, and you have to take up negative here and positive here. Sin A plus B into sin A minus B is equals to sin square A minus sin square B. Cos A plus B into cos A minus B equals to cos square A minus sin square B, and cos square B minus sin square A. Whereas the tan of A plus B plus C formula is sigma tan A minus tan A tan B tan C by 1 minus sigma tan A tan B, means 1 minus tan A tan B tan C minus tan C tan A. Similarly, cot A plus B plus C equals to cot A cot B cot C minus cot A minus cot B minus cot C by cot A cot B cot B cot C cot A minus 1, or else in the same lines as by taken minus common, we can also write as a tan A plus B plus C formula. Coming to multiple submultiple angles, we know the angles which are multiplied by 2, multiplied by 3, multiplied by 4, etc. multiple. These are called multiple angles, and these are called the submultiple angles, A by 2, A by 3, 3A by 2. And some of the important formula related with them are nothing but sin 2A is equals to 2 sin A cos A, 2 tan A, in terms of tan, 2 tan A divided by 1 plus tan square A. And cos 2A equals to cos square A minus sin square A, that is equals to 2 cos square A minus 1 and 1 minus 2 sin square A. The same cos 2A can be written as 1 minus tan square A by 1 plus tan square A. And tan 2A is equals to 2 tan A divided by 1 minus tan square A, and sin 3A, 3 sin A minus 4 sin cube A, and cos 3A is equals to 4 cos cube A minus 3 cos A. Tan 3A is equals to 3 tan A minus tan cube A by 1 minus 3 tan square A. And there's two more important relations which are required, are nothing but which are useful. I'll write here. It is 1 plus cos 2A is equals to 2 cos square A, and 1 minus cos 2A is equals to 2 sin square A. These are very much useful formulae in working out the certain sums. And the same formulae which are nothing but sin, cos, sin 2A, cos 2A, cos tan 2A, sin 3A, cos A, tan 3A. Half angle formulae, sin in terms of half angle formulae, sin A equals to 2 sin A by 2, cos A by 2 is equals to 2 tan A by 2 by 1 plus tan square A by 2. And cos A is equals to cos square A by 2 minus sin square A by 2 is equals to 2 cos square A by 2 minus 1, or 1 minus 2 sin square A by 2 in terms of sin. In terms of the tan, the same formula which you can have it in previously. So the cos A can be written as 1 minus tan square A by 2 by 1 plus tan square A by 2. And tan A is equal to 2 tan A by 2 by 1 minus tan square A by 2. And these are some of the trigonometric functions of some standard angles. No. So sin 18 degrees is equals to, so root 5 minus 1 by 4. Cos 18 degrees is equals to square root of 10 plus 2 root 5 by 4. And tan 18 is nothing but sin by cos. The major one is nothing but sin 18 degrees, we need to remember it. And cos 36 degrees is one more very important formula. and sine of 72 degrees also very much important, very useful results over here. Similarly, we need to remember that sine 15 degrees is equals to root 3 minus 1 by 2 root 2. Cos 15 is equals to 15 degrees is equals to root 3 plus 1 by 2 root 2. Tan 15 is sine 15 by cos 15, which is 2 minus root 3. 2 minus root 3. 75 degrees. Sine 75 is nothing but 90 minus 15 degrees. So therefore sine 75 degrees is nothing but cos 90 minus 15 degrees, which is nothing but sine root 3 plus 1 by 2 root 2. These two are identical equal. And cos 75 is nothing but actually sine 15 degrees, which is root 3 minus 1 by 2 root 2. And tan 75 is nothing but cot 15 degrees, which is 2 plus root 3. Very much useful formula. And 22 and a half is nothing but actually which is 45, half of the 45 degrees. That means we can say that in a by 2 angle, you substitute a is equals to 45 degrees, and if you can write the sine is nothing but so which is under root of 1 minus cos a divided by 2, and a can be replaced by 45 by 2, 22 and a half degree. When you say 45 degrees when I substitute 1 minus cos 45 divided by 2, simplifying you'll be getting as nothing but root 2 minus 1 by 2 root 2. And cos 45 22 and a half is equals to root 2 plus 1 by 2 root 2 under root. And tan 45 degrees 22 and a half is equals to sine 22 and a half by cos 22 and a half, nothing but root 2 minus 1. When you rationalize this one, root 2 minus 1 by 2 root 2, root 2 plus 1 by 2 root 2, and therefore which is nothing but under root of root 2 minus 1 by root 2 plus 1. When you rationalize, you simplify, you will be getting root 2 plus 1. Let's see the transformation formulae. We know sine a plus b is nothing but sine a cos b plus cos a sine b. So when I take up, we know that it is sine a cos b plus cos a sine b. Whereas sine a minus b is nothing but sine a cos b minus cos a sine b. But when you add them, you are going to have two times of sine a cos b, 2 times sine a cos b. When you subtract them, which is nothing but 2 cos a sine b. So in other words, we say this is nothing but actually the sum, and this is a difference. We say the sum of angles, and this is nothing but difference of angles. So sine sum plus sine difference is nothing but 2 sine a cos b. And the sine sum minus sine difference is 2 cos a sine b. Same way, cos a plus b, cos a minus b. We know cos a plus b is nothing but actually. So cos a plus b is nothing but cos a cos b. So minus sine a sine b. This is nothing but cos of a plus b. Cos of a minus b is nothing but cos a cos b plus sine a sine b. So when you just add them, you are going to have 2 cos a cos b is nothing but cos a sum plus cos a difference. And when you see the difference from here to here, when you take up cos of a minus b minus cos of a plus b, you will be getting 2 sine a sine b. In the same way, when you take a plus b in the above formula, when you take up a plus b is equals to c and a minus b is equals to d, and simplifying, you are going to have this one as a sine c plus sine d. So sine c plus sine d is equals to 2 sine a plus b by 2. When you add them and subtract them, you will be getting a plus b is nothing but c means, so a will be equals to ac plus d by 2 and b is equals to c minus d by 2. So that way, so from this formula, we will be getting this formula as sine c plus sine d is equals to 2 sine c plus d by 2 and sine c minus d by 2. So the rest of the formula also can be derived by this way. Sin C minus sin D is equals to 2 cos C plus D by 2. Sin C minus D by 2, by mistake it is plus C minus D by 2. And cos C plus cos D is equals to 2 cos C plus D by 2, cos C minus D by 2. Cos C minus cos D is equals to minus 2 sin C plus D by 2 sin C minus D by 2. These are the actually transformations formulae. So let's take up some of the important time-saving results. So what is the results which are very important to us? Nothing but we know sine square theta plus cos square theta. We know sorry. Secant square theta minus tan square theta is equals to 1. When you factorize this one, you can rewrite this one as a secant theta minus tan theta into secant theta plus tan theta. This can be written as secant theta minus tan theta multiplied by secant theta plus tan theta is equals to 1. So that 1 is the reciprocal of other one, could be written in this fashion. In this way, the same way we can also get it cosecant theta plus cot theta is a reciprocal of cosecant theta minus cot theta. And these are actually the formulae sometimes much be useful. This is called a sine series and this is a cos series. And these are the series which are useful when the angles are in a arithmetic progression. See that alpha plus beta, alpha plus 2 beta and so on. Alpha plus beta, alpha plus 2 beta and so on. So the sine series, this is the formula sine n beta by 2 by sine beta by 2 multiplied by sine alpha plus n minus 1 beta by 2. Similarly, cos series, the formula sine n beta by 2 by sine beta by 2 into cos of alpha plus n minus 1 beta by 2. This is the formula. Let's consider some more time-saving results. If you could remember it, it's okay. But when the time comes, we can solve them. But when you are able to remember it, you can memorize the formula and you can simplify this. So by using cos of cos x plus cos y and sin x plus sin y, or cos x minus cos y, sin x minus sin y, depending upon the sign which you take up, we can derive them by applying the transformations. Tan of x minus y could be either minus a by b or b by a. Sin of x minus y could be either minus 2ab by a square plus b square or plus 2ab by a square plus b square. Okay, and similarly cos of x minus y is equals to minus r plus a square minus b square by a square plus b square. But this one is the most important one. A cos theta plus b sin theta is equals to c. Then a sin theta plus b cos theta can be written as root over a square plus b square minus c. By squaring and simplifying this, you will be getting the result here. Root of a square plus b square minus c. So this is one more result which we remember it. Let's consider now a few related problems related with the inverse trigonometric functions and general solutions. So this is the one most important we need to concentrate much. Why? Because in a CET much of the problems will be related with the inverse of trigonometric functions are coming up. So we need to be very careful about this one. In the inverse trigonometric functions in the PU also, we studied about the existence of inverse of a mapping. So if FA to B is a mapping defined from set A to set B, A is called the domain, B is called the codomain. And then inverse of the function represented as F inverse B to A exists only when F is 1, 1 and on 2. It means F is a bijection. And when the f is a bijection, and when the function is onto the codomain itself is nothing but actually the range. That's the reason f inverse exists directly and from b to a. That's called inverse function. Okay, let us consider some of the inverse trigonometric functions defined as sine inverse x, and when the corresponding domain and the range values are as follows. Sine inverse x is a function defined on the domain -1 comma +1 closed interval, whose range is minus pi by 2 to plus pi by 2. So minus pi by 2 to plus pi by 2. And cos inverse x is a inverse function of the cos x, whose domain is -1 to 1 and the range is from 0 to pi. Tan inverse of x is a function which is defined on set of real numbers and whose range is minus pi by 2 to plus pi by 2. We know the cosecant x is defined in this domain here, minus pi by 2 to pi by 2 except 0. This will become the range of the cosecant inverse of x. And the domain of the cosecant inverse x is the range of the cosecant x. In the same way, secant inverse of x domain is minus infinity to minus 1, closed interval 1 to infinity, and the range is 0 to pi except pi by 2. Cot inverse x domain is equals to capital R and the range is 0 to pi. And this is a domain and range concepts are more important related with the inverse trigonometric functions. So be careful about this range and the domains of inverse trigonometric functions. Clear? Right. Now we shall take up here. We know that if f is any function and f inverse is its inverse of the function, denoted as like this, we know circle f inverse of x is nothing but identity mapping is x, where x belongs to the domain of f inverse, and f inverse of f of x is nothing but x, where x belongs to the domain of f itself. So here f belongs to the domain of f inverse, here x belongs to the domain of f. So in this way, the domain of this function is different from domain of this function, because when you define the function f a to b and f inverse exists when it is 1 1 and on 2, where f inverse domain is b, f domain is equal to a, both of them are different. So in that way, when you take up sine inverse of sine theta is nothing but theta only, but that theta belongs to the domain of the sine function, where the sine is a bijection in the interval minus pi by 2 to pi by 2. Whereas sine of sine inverse x, where x belongs to -1 comma +1, and sine inverse x is also a bijection where x belongs to the domain -1 comma +1, which results in x here. So sine inverse of sine theta is theta, sine of sine inverse x equals to x. You need to remember that sine inverse and sine gets cancelled and it gives us theta, provided theta belongs to the domain of the sine theta. Similarly, the other way. In the same way, cos inverse of cos theta is theta, provided theta lies between the domain, bijective domain of the cos. And cos of cos inverse x is x, provided x belongs to the domain of the cos inverse of x. Let's take up tan inverse of tan theta is theta. Tan of tan inverse x is x, where x belongs to the domain of tan inverse of x. So let's consider now. So in the second year, you might have studied about inverse function value for a negative of argument. Sine inverse of minus x is minus sine inverse x, provided x lies between minus 1 plus 1. Tan inverse of minus x is minus tan inverse x. Cosecant inverse of minus x is minus cosecant inverse x. These are the three functions which gives us with the minus sign directly. So we can just replace with the minus sign and you can write down sine inverse, tan inverse and cosecant inverse. Whereas when you take up the cos function and secant inverse, cos inverse x, cosecant inverse x and cot inverse x cannot give us negative values as minus. But their values are pi minus the inverse trigonometric functions. So cos inverse of minus x is pi minus cos inverse x. Secant inverse x minus x is pi minus secant inverse x. Cot inverse of minus x is pi minus cot inverse x. So pi minus, pi minus, pi minus. Of course, the corresponding x values belongs to their corresponding the domains. Okay, right. Now let's proceed to some of the properties of other properties of inverse trigonometric functions. So we know cosecant theta is reciprocal of sine theta. Does not mean that one sine inverse x can be written as 1 by cosecant theta. So we should write this one as like cosecant inverse x is defined in the interval where x less than or equals to minus 1 or x greater than or equals to 1. Otherwise, we can write mod x is greater than or equals to 1 also. In this domain, cosecant inverse x is defined and that can also be written as sine inverse of 1 by x. Similarly, secant inverse x can be written as cos inverse of 1 by x. And cot inverse of x is most important point. For the positive value, will be written as a tan inverse of 1 by x. For negative values, we write it as a pi plus tan inverse 1 by x. So be careful about this particular portion here. This is about inverse trigonometric functions of the reciprocals. And some of the identities of inverse trigonometric functions are nothing but sine inverse x plus cos inverse x is equals to pi by 2. Tan inverse x plus cot inverse x is pi by 2 for the values of x belongs to R. Cosecant inverse x plus secant inverse x is pi by 2 for the values of x mod x is greater than or equals to 1. R can also be defined as x less than or equals to minus 1 or x greater than or equals to plus 1. And this about the trigonometric identities which are very much useful in simplifying inverse trigonometric functions over here. Right, coming to the fifth property here, actually the concept of expressing sine inverse x in terms of the other inverse trigonometric functions. For example, I take it as a sine inverse of x is equals to theta. That's nothing but actually sine inverse x. We know sine theta can be written as x by 1. Sine theta can be written as x divided by 1. Opposite side by hypotenuse. The adjacent side is nothing but root over 1 minus x square. We know that 1 minus x square. So from this one, we could also express it as theta. So sine theta is x by 1. So therefore sine inverse x is equals to theta. How do you express in terms of cos inverse? So from here, the cos theta is nothing but root 1 minus x square by 1. Cos theta is equals root of 1 minus x square. So theta can be written as cos inverse of root of 1 minus x square, provided this is defined in the required domain from 0 to pi. 0 to minus 1, 0 to 1. Of course, let's consider here the domain with the different values of the domain here, assuming that all the inverse trigonometric functions common domain to be taken over here. Let's consider here cos inverse root of 1 minus x square. In the same way, tan inverse, in terms of tan inverse can be written as x divided by root of 1 minus x square. or cot inverse of reciprocal of this one. We know that tan inverse can be written as cot inverse of reciprocal of this value. Reciprocal of this one, tan. And secant inverse can be written as secant inverse x can be written as here a root of 1 minus x square divided by 1. And cosecant inverse of 1 by x. Let's continue with the same way. The cos inverse x, tan inverse x can also be written in terms of other inverse trigonometric functions in the same as the above slide. Let's consider some of the important inverse trigonometric identities related with the compound angles is concerned. So one is important one, tan inverse x plus tan inverse y is equals to tan inverse x plus y by 1 minus xy, provided x positive, y positive, and xy is less than 1 is the most important one. The same formula will not be equal to directly tan inverse, but you have to add pi. So pi when it is xy is greater than 1, pi plus tan inverse of x plus y by 1 minus xy. In the same lines, tan inverse x tan inverse y equals to tan inverse of x minus y by 1 plus xy when x is greater than 0, y greater than 0, x is greater than y. And tan inverse x plus tan inverse y plus tan inverse z, it is in the same form as like a plus b plus c form. And the tan of a plus b plus c is equals to tan a plus tan b plus tan c minus tan a tan b tan c by 1 minus tan a tan b tan c tan c tan a model. If you remember that formula, this will be easy to same way to recollect the formula over here. Same as here also, when you take up a and b, this is one angle and this is one other angle, and tan of a plus b can be written as tan a plus tan b by 1 minus tan a tan b form. Same way. So this about some of the values related with the tan inverse x, tan inverse y. In the same lines, so we could also express this one, sine inverse x sine inverse y written as, if it is a positive sign, take it as a positive here. If it is a negative sign, take it as negative here. We know when this is a and b, a plus b, sine of a plus b written as sine a cos b plus cos a sine b. Cos a sine b. So x into root 1 minus y square plus y into root of 1 minus x square. The same way, cos of a plus b written as cos a plus b is equals cos a cos b, and the sign we changed sin a sin b. Cos inverse x plus when you take up, here it will be getting minus sign. So cos of a plus b, cos inverse x plus cos inverse y is equals cos inverse x y minus root over 1 minus x square 1 minus y square. And the multiple and submultiple angles. Let's consider the multiple angles over here. We know sine 2a in terms of tan can be written as, so sine 2a, if we can treat it as a, sine 2a in terms of tan can be written as 2 tan a by 1 plus tan square a. Remember that formula like this? So 2 tan inverse x can be written as sine inverse 2x by 1 plus x square. In the same way, the tan 2x, first we take up the cos 2a can be written as 1 minus tan square a by 1 plus tan square a. So 2 tan inverse x is cos inverse 1 minus x square by 1 plus x square. And 2 tan inverse x is nothing but tan inverse 2x by 1 minus x square. In the same lines, we write down that 3 tan x inverse x is equals to tan inverse. If we treat it as a, tan 3a written as 3 tan a minus tan cube a by 1 minus 3 tan square a. Right. If a similar way, that sine 2a is nothing but 2 sine a cos a is nothing but 2 sine inverse x is equals to sine inverse of 2x root 1 minus x square. And the 2 cos inverse x equals cos inverse of 2x square minus 1. And 3 sin inverse x equals to sin inverse 3x minus 4x cube. Cos inverse x is cos inverse of 4x cube minus 3x. You know the cos 3a formula, but actually this is not cos inverse x, sir. This is 3 cos inverse x. There is a mistake over here. So cos 3a, we know the cos 3a is nothing but 4 cos cube a minus 3 cos a. So 4x cube minus 3x. So 3 cos inverse x is equals to cos inverse 4x minus 3x. Let's consider some of the important time-saving results. Here, it's very simple to remember this way. So when I take up here, sine inverse x plus sine inverse y plus tan inverse z is equals to pi by 2. X square, y square, z square is equals plus 2xyz is equals to 1. Similarly, the other results are defined like this one. But when the problem comes, I will explain about how do we go with the angles substitution and simplifying also. We shall discuss about that. Because when you take up, say for example, when I take up sine inverse x is equals to 30 plus 30 plus 30 degrees. Each angle is equals to 30, 30, 30 when I take up. So it is equals to 90 degrees. Will satisfy. So when sine inverse x is equals to 30 degrees, then x has to be is equals to sine 30. Sine 30 is equals to half. So x will be is equals to half. We'll be getting it. So x is equals half means you'll be getting 1 by 4, 1 by 4 plus 1 by 4. So 1 by 4, 1 by 4, 1 by 4, you'll be getting it plus 2 times 1 by 2, 1 by 2, 1 by 2, simplifying, you'll be getting 1 over here. In the same way, by taken here the corresponding values of cos inverse x, cos inverse y, cos inverse z, and by substituting get x, y, z as some specific value satisfying this condition, substituting this values, you'll be getting 1 over here. Whereas here this one will tell you, will explain that one later cases. We'll consider the values and we'll simplify this one. And these are the some of the basic some of the results which are standard results. If you can remember, you can save your time and simplify. Direct answers can be written in the examination, or else we can derive the concept over here. And among these, I think this will be very simple to remember it. We know when it is an angle A, angle B, angle C, tan of tan inverse of x equals to A means x is equal to tan A, y equals to tan B, z equals to tan C, and A plus B plus C is equals to 180 degrees. We know tan A plus tan B plus tan C equals tan A tan C. So this is how we try to simplify the result. Same way, cos inverse x is equals to, each one of them is equals to pi. This is a pi and this is a pi. Cos inverse x is equals to pi means x is equals to minus 1. Y is minus 1, z is minus 1. But this product is 1, 1 and 1. Similarly, the other results. In the same lines, way other one also, we could be able to remember it. We can proceed. So now let's come to general solutions. The trigonometric equations, equations involving trigonometric functions are called trigonometric equations. And their solutions we would like to find here in this one. There are two types of the solutions mainly while solving trigonometric equations. So what are those the solutions over here? The principal solution. Numerically, the least angle which satisfies the trigonometric equation is called the principal solution, which is defined in a particular domain, principal domain of the corresponding trigonometric function. Whereas a general solution is nothing but a solution consisting of all possible solutions of trigonometric equations is called a general solution. Let's consider a set of important results over here. One set is nothing but sine theta is equal to 0, and it is satisfied by every multiple of pi over here where n is an integer. So when sine theta is equal to 0, the general solution of this equation is given by theta is equals to n pi. When cos theta is equal to 0, theta is odd multiples of pi, and tan theta is 0, then theta is equals to n pi, because sin theta can be written as sin by cos, which is same as the solution of sin theta is equals to 0. Let's proceed. Now, the general solution of the equations, one is sin theta is equals to sin alpha. When sin theta is equal to sin alpha, the general solution of this equation is given by the theta is equals to n pi plus minus 1 to the power of n multiplied by alpha, where alpha belongs to the interval minus pi by 2 to plus pi by 2. And cos theta is equals to cos alpha is equal implies theta is equals to 2n pi plus alpha, where alpha belongs to the interval 0 to pi. Whereas the tan theta equals to tan alpha, then theta is equals to n pi plus alpha, where alpha belongs to minus pi by 2 to plus pi by 2 open interval. These are the principal intervals of the corresponding alpha values. So consider the next one is about important things which you need to remember it. While solving a trigonometric equation, squaring should be avoided as far as possible. Why? Because by squaring it, you are bringing up some of the extra solutions over here. If squaring, necessary check of the solutions of extra values. We need to check up the solutions of the trigonometric functions obtained for these values. And never cancel the terms containing unknown terms on the two sides, because that may cause of the loss of some solutions over here. That means cancellation law do not apply in case of general solution problems of trigonometric equations. Coming to the next important one is about the answer should not contain such angles which may contain undefined infinite terms. This is not that much. Okay, let us concentrate on very other important matters over here. Is the maximum and minimum values of a sin x plus b cos x. This is a very much important identity. A sin x plus b cos x values, a sin x plus b cos x is an expression which has got the minimum value is minus root of a square plus b square, and maximum value is equals to root of a square plus b square. That's the reason that the solution of the equation, when you take up a sin x plus b cos x is equals to c, when you take up, this has got a solution only when modulus c lies between, so minus root of a square plus b square and plus root of a square plus b square, a square plus b square. So, and these are the some of the important results which saves our time over here. And in this one, when I take up tan m theta is equal to tan n theta, this is n theta, not theta actually, n theta. Then when you take up the general solution of this one, can be simplified form, gives us the theta is equals to k pi divided by m minus n. Let's proceed. Some of other very important results over here. For equations of the type sin x is equals to k, cos x equals to k, one must check that one, the k value should lies between minus 1 and plus 1. We know because sin theta minimum value, sin and cos values minimum is minus 1 and maximum is equals to plus 1. Thank you.